Do you think that 5 years ago or 10 years ago, Nvidia knew that this is going to happen?
Everybody came to know about the artificial intelligence and AI technology only in November 2022.
Yeah, definitely.
That's when ChatGPT was announced. And as soon as ChatGPT was announced, 100 million people signed up. There are hundreds and thousands of engineers who are working on AI. 15 years or maybe a little more than that before 22. And it's not an easy task. So you have to have, a lot of courage, patience, and a huge amount of investment that need to be put in.
The kind of work that you do at Nvidia, like what is your experience been, your story?
By profession, I'm a chip design engineer.
Okay.
Once the architecture is defined, now implementing that architectural definition into real hardware design, that's where I come in.
So we are welcoming here, and it's a great pleasure of Gyan Vihar and Aestr and mine to have Sir Narendra Kondaji from Nvidia. He's the Vice President of Hardware Engineering, and he's come down from the US to talk to us and gracefully see the launch of Aestr, as well as also he gave great words of knowledge to our students about the changing times and how everyone can adapt to it. So I'll start with that only, sir. I just wanted to see like the perspective of, from you and like your company, one of the, I would say all of like these days whenever there's a new startup, everyone says that it's a wrapper on ChatGPT, right? That it's just a company that's built on ChatGPT. But I think ChatGPT itself is a wrapper on Nvidia, right? It's just if Nvidia wasn't there, there wouldn't be any ChatGPT. So it's amazing that one company's impact has been that great. Do you think that 5 years ago or 10 years ago, Nvidia knew that this is going to happen?
It's my by the way, it's my great pleasure to be coming down to Gyan Vihar University here, participating and talking, to professors and lecturers, like you and the students at large. So it gives me an immense pleasure to be, sitting down and talking to you. So as far as this artificial intelligence technology goes, everybody came to know about the artificial intelligence and AI technology only in November 2022.
Yeah, definitely.
That's when ChatGPT was announced. And as soon as ChatGPT was announced, 100 million people signed up in about a month. This is the fastest sign up, in the history of any application, any app, right? So that's a testament to the impact that this AI technology had in what the people were doing, and they communicated with their friends, and by word of mouth or by whatever means, it spread like wildfire, right? Because there was something
real value, real impact.
That's the reason why 100 million people signed up. If it was not beneficial, why would anybody want to use it?
You can't push it.
Right. So that's in November 2022. But there are hundreds and thousands of engineers who are working on AI, 15 years or maybe a little more than that before 22, right? And engineers, like me, were working on this for a long time. And it's not an easy task. It's not, this is not a subject for the faint of heart. So you have to have, a lot of courage, a lot of patience, and a huge amount of investment that need to be put in, billions and billions of dollars over a long period of time to make something like this, to make it real, right? But we believe, in the concept. We knew all along that the graphics processing unit GPU had, inherently it has a tremendous amount of computational power. GPUs traditionally were used for gaming. For gaming.
Yeah.
So fantastic.
Displays and gaming.
A great application. It gave joy to millions and millions of People, the gaming industry is really, really big. One of the biggest industries is the gaming industry.
Yep.
Right? But we knew about the power of it. To run a game in real time, when a user moves the cursor, for example, you have to redraw the picture, the entire picture, you have to draw it in real time.
Every single pixel.
Every single pixel, every single frame,
Yep.
Hundreds of frames, you have to draw it.
Yep.
And this all has to happen in real time. Right? And that's because it had that computational power. So now the question is, if that thing has that much computational power, how do you use it for other purpose? That was the question.
True.
How do you use it for other purpose?
That was the question.
And that's when this concept of GPU came into picture.
True.
That is general purpose graphics processing unit. That means how do you take this gaming GPU and put it for general purpose use? So that was an experiment.
You could do neural networks on it. That just went.
And so Nvidia went and collaborated with a lot of
hundreds of universities, definitely.
Right? And we taught them. Back in the day, students were taught how to program for a CPU.
Yeah.
And that is a serial programming. Right? Now, GPU is a highly parallel engine.
Definitely.
That has hundreds and thousands of threads. Hundreds and thousands of computational cores within a GPU.
Less complex, but more in quantity.
More. Yeah. But how do you program for it? The academics, were not, taught. The students were not taught. So Nvidia had to go out, collaborate with, the researchers,
build their own community around it,
and build a community around it. So it was a long, long, long road, and we went and taught the students,
that was the genius
about the parallel programming. Right. So it's been a long journey.
And then build CUDA layer on it and everything around it. The whole community is almost dependent on Nvidia now. You can't really replace it. So just going, a little bit deeper in it, would just love to know from your perspective, how is a GPU actually made?
Everything starts off with a spec, right? So how does what should our next GPU look like?
Okay.
Right. So you look at the existing GPU, and you look at the workloads that are running on the GPU, right? And then you ask and collaborate with the industry, with the people that are using it, right? And you benchmark it and figure out what is it that is lacking. Because on the software side, it is evolving so fast, right? So this community tells the designer of the GPU what is good, what is bad, or what is lacking, right?
Makes sense.
Now that input is the specification for the next GPU, right? So that's where thousands of engineers at Nvidia, they start off, with a spec, right? And of course, a very high level model of all these concepts, the new things, gets written, and they get simulated and validate if what we are doing, whether we are on the right track, whether the performance that is desired is going to be there or not, right? And that's the architectural specification. There's a huge architecture team, right? That validates the idea, the concept. Then comes the engineers that really design the hardware itself, right? And so we have, again, hundreds to thousands of engineers that work on that, implementing that architectural idea, into this real hardware design, right? And now that after that is done, now this has to be, this hardware description of the GPU has to be translated into a piece of silicon.
Right? Has to be.
Now there is transformation of this hardware design that is done into the nuts and bolts, and the transistors and the wires, going millions and millions
Silicon
of
chips,
wires.
yeah.
They are not millions actually,
Yeah.
billions,
Billions.
billions of transistors
Yeah.
and billions of wires.
Yeah.
That need to be translated into that hard, that physical structure, and that physical structure, then gets sent to a fabrication plant. Typically the fabrication plants today are in Taiwan. Pretty much, TSMC. It's a predominant
nanometers. We've got to 7 nanometers, 2 nanometers now.
Yes. So it goes to TSMC. That's where
Real
the
fabrication
GPU
happens.
really gets made.
Yeah.
That's when the silicon, a physical chip, comes back.
Yeah. So, what's in, why is Nvidia such a powerhouse behind it? What's the moat around it? So, my question, like the background of this question is that I'm sure that at the time when Nvidia started, there were lots of companies in Silicon Valley exploring graphical cards, right? So, they defeated everyone around them at the time. And right now, there's the whole country efforts, like China is trying to build it. Big countries are trying to build it, and they can't compete with Nvidia. What's behind that powerhouse? Like, why is it that you can't really catch up with Nvidia?
Yes. So in Silicon Valley, there were 60 graphics companies that I can remember.
Yeah.
And I used to work in one of those graphics companies called as 3DFX.
Okay.
3DFX Interactive. It was there was a very close competition between 3DFX, where I used to work, and Nvidia.
Okay.
They were very they were equal.
Early 2000s.
So yes, this is early 2000s that I'm talking about.
Yeah.
2000, 2002, 2003, around that time. You would see every year this number, 60 graphics companies were there. Every year the number would shrink. It would shrink. And finally it came down to, early 2000. Now I'm talking about, 90s and then, 2000. By early 2000s, there were hardly something like 5 to 6 companies, not more than that. About 5 companies.
Okay.
And, among these, 5 to 6 companies, 2 companies that stood out was 3DFX and, Nvidia.
Okay.
Right? Now you ask me why, how did Nvidia, succeed? One of the things I would say, it is the execution.
Okay.
Nvidia is a master executor.
Okay.
Once you put a date on something, that it has to be completed by that date, by that date, it will be done.
Okay.
It will be done. Okay. I would say that is the main difference, right? In those days, if you do not ship your chip, your product, at a point in time, there are very critical milestones. If you're late, then that is the end of that company. That company would die, literally.
Really?
Literally, if you do not release the product on that particular date, everybody has to.
Because your clients will be waiting for it.
Because
they
the clients
will put it in their own laptops.
Into their laptops, into their desktops, right? And if you do not bring the solution to them, in time, they would move on. They would sign up for whoever company gives them, right? And because it's a high capital intensive, industry, if you do not, sell your product, basically that's the end of the company. True. So that's how lots of companies, died. And so I was at 3DFX, so there was a big, very big competition. We meaning 3DFX, was late to the market by 3 months.
Oh.
Nvidia had released a product 3 months before 3DFX.
And that made a huge.
That was the end of 3DFX.
Really? Okay.
See how much a big difference, 3 months make.
Mm-hmm.
Right?
Made the future.
So I would say that is one of the reasons, right? And it's being disciplined. That's another thing. Engineering discipline is very, very, very important, right? You cannot change your goals, every 2 months. Okay. It's an engineering is a never-ending problem.
True.
You can continue to make the best product, right? True. And you can spend another 5 months, another 6 months.
True.
But the industry is not going to wait. Your commercial, because your life depends on how much money that you make in the market. right? So that market isn't going to wait. They will go with this whatever solution that is there. So it is the engineering discipline. That's, I would say, another quality that distinguishes successful.
So plan and
companies from-
execute. Don't keep changing your plans.
Yeah,
Well,
don't keep changing plans, right? Whatever you plan, just go ahead with it. Just go. Now, if this great idea that you have to put into the product, well, do it.
in the
Do
future.
it right after you release it, and
Okay.
do it in the next one.
Yeah. This is a constant problem that I keep having where I would have these new ideas, and now with like AI, you can do faster iterations.
First iteration.
But you do get into this trap of, like, let's just do that before we launch again.
Yeah.
But that definitely I can like align
Right.
with this issue.
So you talked
Yeah,
about it
yeah.
is a very you can do iterations
Hmm.
very fast, but the technology is also moving so fast.
Exactly.
Early 2000s, months
Months
maybe
matter.
mattered,
No, days
but
matter.
now it is days. I mean, you can see in the market what is happening.
Yeah,
The different companies that
Yeah.
are releasing OpenAI.
Every 3 days,
Perplexity,
there's a new thing.
It's a new thing.
There's a new.
And the reason is that it's how fast the industry is moving.
So
you
have to
cannot
release,
afford to wait.
Execute fast.
You cannot say, well, I will wait 2 weeks and then I'll release. No, by then that idea, whatever you had, is already implemented.
Someone has to have done that. Oh, that's great advice. Like personally, also I would take that. And lastly, sir, just wanted to know your the kind of work that you do at Nvidia. Like, what is your experience been? Your story, so that students can also relate to it as and see their
Okay.
future in you.
So by profession, I'm a chip design engineer.
Okay.
Once the architecture is defined, now implementing that architectural definition into real hardware design, that's where I come in.
Right.
So within the design engineering, design engineering, there are multiple disciplines, in this one, right? One is people that are writing what we call as Verilog,
Yeah.
code,
Yeah.
right?
VLSI.
That's one set of engineers are doing it.
VLSI programming.
VLSI programming, right? Now, whatever is written, ultimately it has to be verified.
Yes.
So writing code, it so happens to be that's one of the easiest things to do.
Yeah.
Writing code isn't that difficult.
It
right?
is not.
I would not say it is trivial.
Yeah.
But at the same time,
I
it's
can
not great. Well, you can write it.
Yeah.
But the thing is, whatever you have written, whatever you have developed, well, does it really work?
True.
So finding out whether it really works or not happens to be one of the toughest things. And that is the verification engineering, verifying something whether it works or not. And that's one aspect of it. Then integrating it into a system environment. Okay, you have this standalone thing. Well, but that thing has to integrate itself. It needs to talk to the memory. Well, it needs to go fetch the data, from somewhere. Somebody, a camera is, sending the data to this guy, right? Or this guy is trying to send.
Yeah.
So now you have number of components around it, which is a system. So that system integration is
Absolutely.
a key thing, right? Now, so that's where I come in.
Mm-hmm.
Just making sure, verifying the design itself is functional by standalone. Now, when I take it and put it in the system, so will it work or not? So now, how do you do that, right? Now, so that I use a special technology called as emulation, technology. These are one emulator is probably the size of this room.
Really?
Size of this room is one emulator.
I was imagining something like a computer architecture board.
No.
Okay.
No.
Okay.
If I want to implement the one of the latest GPUs, basically, what I create is a physical representation of the GPU before it really gets fabricated. So in my lab, I already have a GPU, but that GPU happens to be sitting in an equipment that is the size of this room, but it is actual GPU. It works and behaves just like a GPU, but not as
it's not on silicon.
It is not on silicon.
Okay.
It is a massive room full of equipment. And in that room full of equipment, that equipment is programmed
Yeah.
to behave
Emulate the actual.
emulate the actual GPU.
Yeah.
Well, it doesn't run as fast as the real silicon.
But you can
would
check the
run.
network interfaces and all the parts.
Right. It doesn't run as fast as the real silicon would do,
Yeah.
but it works exactly
Same.
like the real GPU. So if I have an exact GPU in my hand, even though it runs little bit smaller, now I can run some workload on it.
Yes.
And then see if it really works or not.
You check the core-to-core traffic.
Yeah, so you run massive amount of software on it because it is pretty much next to the real GPU. It is actual GPU, but it runs a little bit slow. Yeah. But you can run software on it. You can run any number of workloads on it. Yeah. Now, if it doesn't run, whatever you're trying to run, well, there is either a problem in your software that you have written, or there is a problem in the hardware design. Yeah. One or the other. Yeah. Right. Sure. So that's where the debugging happens. Yeah. So we find out, is it this guy that's the problem or this guy? Or maybe both of them, may not be able to talk to each other. The protocol, isn't implemented properly. Okay. Right. Or within a GPU itself, you are working on one engine, let's say you're working on some video, video engine. Okay. Okay. I am one of the unit designers within the GPU, and I happen to be working on a camera, interface. My job is to take the input from the camera. Mm-hmm. That's what I developed, my engine, and I give it to the engine that you are working on, which is the video. So you process the video that I pass on. Yeah. Right. Now, if you and I, don't understand each other, and I'm looking at the spec and I implemented the spec in one way, and you are looking at the same spec, but you implement it in a slightly different way. Yes. So now when we bring your unit and my unit, these are small pieces within the big GPU. Yeah. So if just two units are not able to communicate with each other, then the entire GPU just falls flat on its face. So it is that, that's making sure the verification and the integration of not only the units within a GPU, but the GPU itself communicating with multiple other external, chips and processors, system integration. So this is the fun environment that I live in.
Sir, as an electronics engineer, and I can say this for anyone who's actually, is interested in it. This is actually like the thing. I was telling you this before. This like raises goosebumps when I hear about these things. Like you're directly working with Nvidia Jetson and things that are like impacting the world with real value so much. Yeah. The last question would be just about just your comments on the first of all Aestr as like what do you think we should do? What do you think? Do you think like there's value in the concept? And the second comment on where we are trying to use AI as a teacher also to have a more interactive one-to-one approach to any student from like a 5-year-old to a BTech student to be able to interact better, learn better. Our aim has been that it's not just for the top 1% student who are self-motivated and learn themselves, but all the rest 99% students who don't get the one-to-one experience and they need that. Yes. So Aestr and the education.
Yeah. So I watched the presentation on Aestr with great fascination that you gave on stage, along with these two guys, that are on the table. Yeah. It's very impressive. It's a noble endeavor. One of the things that you presented is that showed AI, right? Now that the teacher model, right? Just believe, millions and millions of students are living in very remote
there
places.
Are no teachers there.
There are no teachers. Even if the teachers are there, they are not too knowledgeable, right? But there are gems, everywhere, brilliant minds everywhere, but they don't have access to the technology, somebody to, teach them. And it really doesn't matter which subject it is. I'm interested in design, fashion design. Somebody is interested in designing, GPUs and, CAT GPTs and so on, right? So what is lacking is the infrastructure. And, especially, in the developing countries, not only in the developing countries, even in the developed Western world, this problem is there.
Definitely.
Even in the Western world,
There's
right? There is lack of knowledge communication, right? So that show the AI, initiative. That's a fantastic initiative.
Thank you so much.
It just it helps a kid that is in the first grade, right, all the way to the master students or a PhD student.
Thanks so much.
Right. So I would I really I congratulate you. That's a noble thought that you have. Please continue to enhance
We'll try
it
our best.
and just make it available to either commercially or however, whatever may be the means, whatever may be the means, right? Just spread it. I mean, you would be doing a service to humanity, I would say.
Thank you so much, sir. Thank you so much. It's so great to be
Yeah.
here.
Thank you. Thank you.